Hey, what's up there, viewer? Welcome back to this Nebulous live development creation series. I apologize, we got a cat who's making a little bit of noise back here, but I think he's gonna run off now. Okay, so this is day 10, hour 2, and in the last video I was situating some of the code for random system spawning. I devised a bunch of prefabs for different things that the player could scan down, different parts of the solar systems, and I had just settled on this random generation code, which is able to instantiate planets and actually, whoops, I did this wrong here. It's actually able to instantiate, so this is a signature prefabs. The idea is that this will actually generate a system. It can generate system positions. And it'll actually instantiate the objects. The one thing that is missing at this point are the random positions. Which is going to take a little bit more thinking here. I'm going to, for testing purposes, comment this out. And in this instance, we just instantiate a sun at some position, which is where turning this into a function may be prudent. For spawning other systems, I still have to decide how to design that. But effectively, what I need to sort out now is I've got to create random positions around the sun. For placing these signatures. And I'm trying to do it in a way that is paternal. Or, actually that's not paternal. Because if it's paternal, like I was stating earlier, it's easy for the player to like tell that it's like not organic. So to give it an organic sense, my original idea was like use the Fibonacci sequence to more or less spiral out from the galaxy, and then like at certain points along that spiral place things. However, I was looking at the math on Wikipedia for the Fibonacci stuff, and it was like rather involved. So I'm going to start off by trying to use my other idea, which is to simply pick multiple radial values and essentially at that radius then pick an arc, and at that arc make it a random point, more or less. And that will be, I can even like devise a way to sequence the I can even find a way to sequence the random arc to be more organic and not purely random, because essentially I'm trying to land in the middle of purely random, which could yield to really strange bunching of celestials, as opposed to perfectly uniform, where it's just very obvious that they're all exactly the same, like a distance apart from each other, which is something the player can notice. So the middle ground is like, I can fix the bunching by having the separate radial tiers to a large extent, and then I can spread them out using some kind of random determinants. And I guess I'm just going to have to get a feel for how it looks, because the player can certainly notice the patterns, typically. So it's got to be just random enough to be good and be non-fraternal is effectively the goal. Alright, so to pull this off, more or less, what I'm going to need is I'm going to need a vector-free array for random spawn points. This is going to be a new vector-3 array, and it is in fact going to be of the length random signature count, because each count needs a point. And I suppose we're going to have to pick each point if I can spell it correctly, of course. We're going to have to take each point and assign it a new vector-3 more or less. Then once we have this assigned properly, all we have to do is come in here and I can do it on both of them. We just have to come in here and simply say random spawning points at I. And we have now accomplished instantiating at random positions. We're probably going to need a vector-3 for current let's call it current point. It's a new vector-3. And in here, we have to say current point equals this, actually. But we are, in fact, going to do some custom work on setting current point. Where effectively, for now, I am hard coding it all flat, so it matches the scan system. However, due to how nebula volumes work in this game, there's a good shot that eventually I'm going to be expanding the scanning system to be spherical, not just radial. And in that instance, the player can actually scan three-dimensionally, which would massively increase AoE scans, stuff like that. So like I can understand why this is going to be 0. However, we're also going to have to Alright, sorry, I'm trying to consider how to do this. So another thing we're going to need, more or less, is each spawning point is going to have to I don't know if this is necessary, but I'm feeling like doing it for now. It's the same number. The random spawning points. Each random spawning point has a radial value, more or less away from the sun's position. So I'm kind of feeling something like this, a float array for random radial values. And to the same degree, it's each signature gets one. This is going to ensure that this is more or less going to ensure that no no signatures spawn within like very similar orbital distances from others. And I'm wondering if I want to just go like this and separate this out into a separate for loop. Something like this. And this is actually it essentially exists in the form of a floating point here. So public float, and that's distance between radial segments. And more or less, this is just going to say random radial values at I equals current random radial value and each time the current random radial value has to add the distance between radial segments to it. And this is more or less going to just generate an array of radial segments, which are simply spaced by a few things. One thing it's going to do is it has to be at least this star's size. Otherwise, things have the chance to spawn inside the sun, which doesn't make sense. So I'm going to need to just go like this, game object star. And then I'm going to have to grab the transform of this. I don't think I can do a scale exactly. So I can do a transform. That just equals star dot transform. And I might not even have to do that. I might be able to just grab it off the star. So star dot transform. And actually, I'm curious if I guess I can just assume that if I'm assuming the suns have equal x and z values in their scale, I can grab either the x or z value to determine the radial value of the sun. So I do something like this. Oh, let me see if there is a radial something or other. I don't think so. So I'm just going to do this pretty straightforward and say, yeah, dot x. And that will assume the radius of the sun. At least, which isn't enough by default. So we also have to come up here and add another value, which is public float. And we're adding this is essentially buffer distance between star and first element, or first signature. Makes sense. And whatever that buffer distance is, we are adding to this. So BD, BS, AF. Okay. And this is effectively going to make sure that it's always outside of the sun, variable to a degree that we decide. So we can decide on I'm kind of considering a ratio. So kind of what we want is we want racially speaking, the like we want the same percentage of distance for separate star sizes. So if one star is like, you know, a theoretical radius of 1 and the buffer is 1, then we have effectively created a buffer that is 100% the radius of the sun. Whereas if the sun is 0.5 and it's 1, now it's 2 times the radius of the sun, whereas we would like it to be 0.5. So I'm actually going to change this, and I can basically cinch this up into one value. So I'm going to call this buffer ratio between star and first signature. And we're going to do this math a little different by saying this equals itself times the buffer ratio between star and first signature. And this is in fact going to more or less make sure that the first signature is like some set percentage from the star for every star. That way different sizes of stars have like a kind of a uniform space between their edge and whatever their first thing is. That way bigger stars have more space from their first element, and then smaller stars have less space from their first element, but they're all defined by a global variable, which makes it very simple to just say like 1.5. And then everything starts spawning about 1.5 or 150% of the radius of the star away from the star. Okay, so that makes sense. And then from there, we simply add the distance between radial segments, which this could also get a slight scalar, but it might work out well enough due to how spaced the signatures are radially. Because of how spaced they are radially, it might not. The player might not notice that this value is the same. To a certain extent. Alright, and this will effectively this is effectively going to determine our radius. Or more specifically, it's going to determine the distance from the sun. So now that I have a array radials that match these spawning points count-wise, I'm going to have to like probably use the sun's position plus vector3 dot forward times the radial value, and more or less what that's going to do is stick stick the celestial at forward at a radius, and then rotate the object around the y-axis at that point. And more or less, I'm pretty sure that should actually move the point to a position that I want. Okay, so for that I'm going to need current point equals, and we're looking at star.transform.position plus vector3.forward local, and I can just, it assumes forward, and it's going to be forward times random radial value at I. And that is more or less, so if this works correctly, we'll actually, it should spawn a random line of objects. It says I'm not using current point, but I am. And since I suppose since it's being a little annoyed by that, I'm just going to go in here and go like this. My idea was I was trying to cache it for memory, since it's going to run this a few times, but okay, so now we'll instantiate random stuff in a straight line forward of the sun. So I think that's a good place to give it a test here. And let's see here, on the system, minimum signature spawn, maximum signature spawn, and I'm confused off the top. Was that just a total count of spawns or something? Yes. Oh, wait a minute, did I even work that in anywhere? Okay, good. So I'll keep this simple and we'll say like 3 to 15. Distance between radial sections. I mean, all of our prefabs are only like 1 unit, right? So I can just, I guess I just call it 2 to be safe. And then the buffer ratio between the star and its first spawn, I'm going to set that to 2 because usually there aren't things like right next to the star. They're moved away. And I do believe that's basically everything. So now I just need to give it a shot. So essentially, when I enter play mode, what should happen is we should get a random star, and then in a straight line, as if it's a planetary alignment, there should be random signatures that include planets and resource signatures. So I guess we might as well just take a look here. Alright, and that's actually basically correct then. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it even only has 10 signatures. So we've got some kind of blue star, and we've got whatever these are. And these are actually spaced by 2 units. But obviously, like a normal sized like Earth continental planet. versus like a gas giant might have a huge difference in radial value. But so I might need to add an effector that takes the last radius and adds a buffer, sort of like the star buffer. And that way it just kind of buffers between. The thing is though, is that once these start to rotate around the star to some degree, that won't matter as much, because like they'll be in different places and the size of them won't be as big of a deal, more or less, is the idea. Okay, so let's see if it actually randomizes properly on the restart. Or let's see if it's seeded into the same values or not. Alright, so this time it was different. So this time it's like a yellow sun, and it's got an asteroid belt, possibly a gas giant, maybe an ocean planet. Which is a pretty weak star system, but that's sort of how it rolls. Okay, but that's basically working. So like now all I need to do is figure out how to set up the rotation value. And this rotation is this is more or less, for a better term, the local rotation of the object. It's not what I'm looking for up here. So up here I've got to consider okay, so the vector 3 point is going to have to rotate and to rotate that point I very simply have to come in here and say current point equals, and then I have to say quaternion. I've got to pick, I guess off the top of thinking angle axis. The problem is that I can't rotate past 180 degrees with a quaternion. I can give it a shot though, see if they change that. And it's going to be around the up axis, and it's the quaternion times the current point. So now we're just simply looking at how to determine the random angle. Once again, without producing paternalism. And I guess the most straightforward thing I could do is just do a random range. Oops, random.range. And it's just from 0f to 360f. So this might work. It'll work to the point where it like picks random values that are the same a couple times. So if it might just pick 3 values in a row that are like pretty close to each other, and then you'll have 3 things spawned pretty close to each other, which isn't quite what I was hoping for, which is kind of where I was looking at the Fibonacci sequence, because it would distribute them more evenly. The other thing I can do that I'm thinking is use like for the first 3, lock them into being guaranteed to be like like 120 degrees apart, and then each of them gets like a random shift between like -30 and 30 for each system, so that way it doesn't look like a triangle every time. and then the next 5 would have 5 points that are guaranteed to be not on the first 3 points, basically. And you just keep scaling it up, more or less, and it will distribute them. It'll kind of make sure that they get distributed throughout the space more evenly, while still retaining a little bit of randomosity. But for now, I can go pure random and see how it works. So let's take a look. And that is effectively and that's more or less how it's supposed to go. And as we can see with the randomness set like this, it's like these 3 are like bizarrely close together, right? It almost looks like these 3 are like, it almost looks like these 2 are like next to each other, or like in the same radius, but they aren't. Like this radius and this, all these radii are different. They're guaranteed different radius, but I think for prototypity's sake, it is good enough to get across what I'm trying to get across, which is that each system has to have the capacity to spawn itself a different assortment of signatures. See, there's a kick-ass system. Dang, that maxed out. That maxed out the randomness. And so here's what I was talking about with close radial values having roughly the same random rotation, because you know these effectively rotated to like about the same spot, and there's a way to make it to where things that are close like this are guaranteed to spawn in separate sectors, and it would actually space the sectors more evenly. So like right now it's pretty random, but like it could get, there is a way to mathematically uniform it more or less. So there's definitely a lot more to do for this, but this is more or less functionally correct. And if I want to add suns or remove suns, I can. If I want to add planets and signatures or remove them, I can. So the system is scalable, and there's room to improve the randomosity. And then there's little things like making sure the sun is like humongous compared to the rest of these. But, and let me see. So it is throwing me a little error here, and I think that's just because it's just because it's not, I guess it's just because it's not null guarded. Or in this instance, it's simply because there isn't an active scanning radius object at the moment. And that makes sense because I kind of yanked that out of there. Which is what I did. You actually instantiated it on the capital planet. Alright, so the only thing then is that if I if I try to select something, it does give me this error, which is suggesting that, let me see here, there isn't an active scanning radius object. And then this isn't breaking for some reason. And I think that's probably because I haven't added like these components to any of the selections, perhaps. Is my best guess. Because effectively it's suggesting that whenever I click on this, there's issues. So really quick, let me see here. Okay, so here's the sun. No components, just a sphere collider. And I think it's the same for these two. Oh, that one has a rigid body. Okay, so these have rigid bodies. But for some reason, I mean, they should basically be working. The planet has a rigid body on it, and it should be configured the same on all of them. Yeah, I mean, so this, I can't imagine this is the issue directly. This doesn't have a rigid body, of course. But these do. I'm not sure why. Maybe for, I thought it was maybe for this. Okay, so I get that part. That's in a very particular case, though, where the current active selection is not null. Oh, okay. So on the reset, it's what's messing it up. Okay, I basically get that part. This is what I'm confused on. Star system view. Select active selection. Which is handled in I was under the impression it was named something a little different than that. Is this the raycast code or? Oh, there's raycasting, okay. Oh, this is this one. Alright, so let's think about this here. So that's a little bizarre. I mean, it all should be working still. Current action map is set. So anytime I click, it's supposed to just do this. I didn't change anything in particular. The only thing I could imagine would be this is... Oh, it's actually used in a lot of places. Okay, so more or less I could probably fix this by bringing this into the game arbitrarily. However, I'm now getting into a different issue, which is that this is supposed to start on the player's home planet, which means now I have to like pick a system randomly to be the player's home system, which we could assume is our only system, but in the next step, where the galaxy generates nebula, the nebula are assumed to, or most of the nebula don't need the capital planet. Okay, so now getting into some interesting design choices once again, because the player out of the vast galaxy gets one starting planet, and in that instance, should they have a random chance to get a starting planet of any of the types, or should I lock them to a continental planet to start? That's more of a design thing. So for now, if I can make it easy and just have any potential planet be the starting planet, even a gas giant. And if I don't like that, then more or less, it's almost like at the galactic level, okay. Yeah, I don't know how to do this exactly. I have to like, it would be very easy if I knew exactly how many planets there were going to be. I could more or less just do a random value within that range, and then whichever planet it picks is the player's planet. However, I'm not sure if the game is going to have that information at the beginning, because then it would have to be like calculating. It would essentially calculate its total planet count, which that might actually work. I could effectively expand my algorithm here to cover all signatures throughout the entire game space for each star. So like at the galactic level, it would be able to pick a random number of nebula, and then for each of those numbers, pick a random number of stars, and then for each of those numbers, pick a random number of planets, and then increment a planet counter. And from there you'd have the count of the planets, not actually each physical planet, and you could just pick one. But in order for that to work, then also there would have to be a like a cross-referencing value in order to reference back to which star this planet is orbiting. Which is an entirely new system, more or less, where like each of those integers has to staple itself onto the star integer. So I'm kind of envisioning something a little different where like each time a planet is generated, it like okay, I have another idea. And essentially that idea is, well, I guess that's not going to work either. Okay, so now I'm wondering about generating the galaxy. Because if the galaxy generates top down, then more or less it's going to like decide all the positions up front, which may not be necessary. That if I build it from the bottom up, it'll still kind of take all right. So how it's exactly designed now, there is a random chance that the star spawns no planets, just signatures. It is technically possible. In that case, the player can't have a in that case, the player can't have a in that place, that star can't be the player's home system because there isn't a planet. So I can't just pick any random well, I suppose that's pretty rare. So what I could do, in fact, is pick a random star, or I could even do it recursively, and like pick a random nebula, then pick a random star, but then I have to check if there's a planet, and if there is or are planets, pick a random one of those planets. And that kind of allows it to tree down to a random selection without requiring the entire collection. But and then I'm getting back into top up or top down versus like bottom up kind of thing. So if I just had like if I had infinite computer resources, the idea would be I could just do the rote way and just have huge collections of everything. But I'm anticipating in the future that I'm going to need to be dynamically creating and destroying objects, or at least, you know, activating and deactivating them or whatever. Dang, okay, so A, I'm just trying to figure out a way to do this efficiently because there's so many potential stars. Dang, I apologize for the silence. I've got to really make sure this works right because if I don't do this correctly, it'll be asking for a bazillion things from the computer, which isn't great. All right, I'm getting a little mixed here because a complete top down is going to require the player to have like a load screen depending on how big the system is, and my idea would be to in fact minimize the load screen by only loading in the player's starting system by default and then kind of building out the rest of the stuff like asynchronously. So that way the player can jump right into their main system and then essentially spread that load screen over however long it takes for them to start expanding to the systems around them. So to do that, if I just go with the top-down thing, by generating every nebula, every star, and then every planet, or at least the counts of those, a couple job structs might make that go quick, since it's basically just numbers. Even though they might be large numbers, like large collections. The problem though is then you're adding extra code every time to test if the star has a planet or not. And then you effectively would have to grab a new array that is the index of every star that has a planet, and then from that you would pick a random one, and that index would provide the star that becomes the global, or the star that becomes the starting system, and then the random value for which planet is the starting planet. And I suppose that could work. All it's doing is, it's not actually like instantiating any game object, and it's not actually instantiating anything. It is just counting how many nebula exist, how many stars exist, and how many planets exist. Or, more specifically, it's determining the number of nebula, and then it's generating stars, or it's determining the number of stars, and then it's got to determine at each star if that star has any planets. And if it does, it's got to pass its index into a collection of potential starting stars. And then once that is collected, a random value is then picked from those stars, and then that star becomes the starting star system. And then since it has a planet, it then basically can just do a random pick on one of those planets, and that's the starting planet. And it can get more specific on picking continental or whatever, but I suppose what that ends up doing is that almost ends up identifying every single nebula, star, and planet by an integer. So there's almost a guaranteed integer identifier now, if I do it like that throughout the whole game. Alright, well, I've still got to do some thinking for how I want this to be built. This idea I'm thinking of right now would work. There's a lot of potential issues with like cross-referencing the identifiers. Although the integer key makes a little bit of sense, but the only other thing I can imagine is every time a planet is deemed in existence, there would have to be some kind of micro-randomized roll on that planet. And more or less, every single time another planet is found, the chance of that micro roll going up, or the chance of that micro roll succeeding, like, goes up by a small number, a very small number. And effectively what that does is each planet has a chance to be the starting planet, but over time, as the random selection fails, it increases its chance to succeed. So that way, more or less, a random planet is picked at some point based off of this separate little algorithm I've got. And it wouldn't have to do the whole count thing. And then eventually it, like, chooses the planet. And it's basically random. And I can scale the balance so that it feels differently here and there. So I'll have to consider it. Alright, so I apologize for that. We actually made a pretty solid push here through getting this randomization started. So now all I need to do is set it up to where the... See, that was actually pretty good. Now all I need to do is set it up to where I can deem a starting planet somewhere, and then after that I'll have to set up like a nebula with multiple star systems, and then the galaxy with multiple nebula, and the random system will actually be set up pretty good. So alright, this video is pushing up to an hour plus, so I'm going to call it for now. Take care, thanks for watching, I'll see you in the next one, and I'll see how much further I can get.